Okay, in this video, we're going to talk a little bit about negative and zero exponents. In this course, we mostly work with positive exponents, to the power of 1, to the power of 2, to the power of 3. I'm just going to show you how we can use patterning, a little bit of an investigation to figure out what happens when our exponents become negative. So I'm going to first work with a base of 2. 2 to the power of 5 is 2 multiplied by itself 5 times. If I did it in my calculator, I would get 32. 2 to the power of 4 is 2 multiplied by itself 4 times. 2 times 2 times 2 times 2 is 16. 2 cubed is 8. You probably know 2 squared is 4. 2 to the power of 1 just means it's 2 once, which is 2. So we all are pretty familiar with how to work with positive exponents. What happens 2 to the power of 0? Is it 0? It doesn't really make a lot of sense to say it's 2 multiplied by itself 0 times. But if we look at the ones that we've already done, what's the pattern to go from one to the next? Well, it looks like to go from 32 to 16, I had to cut it in half, or I had to divide by 2. Same thing, from 16 to 8, I'm dividing by 2, dividing by 2. So I'm always dividing by that base, which makes sense, right? Because I'm multiplying it one less time by 2, which is the same as saying I'm dividing it by 2. So let's keep that pattern. 2 divided by 2 is 1. So it makes sense that 2 to the power of 0 is going to equal 1. Now negative exponents, well, what does that mean? I'm multiplying 2 by itself negative 1 times. Well, let's just keep our pattern. What's 1 divided by 2? Well, that would be 1/2. I'm splitting 1 into 2. If I split half into 2, if I divide by 2 again, 2 to the power of negative 2 is going to be a quarter. And 2 to the power of negative 3, well, half of a quarter is just an eighth. And we could rewrite some of these. That's the same as saying 1 over 2 to the 1. And 1/4, another way of writing that would be 1 divided by 2 squared. Or 1 over 8 could be 1 divided by 2 cubed, or the reciprocal of 2 cubed. So we see a couple patterns here that I can always divide by the base as I decrease the exponent by 1. And when I get into negative exponents, I can think of it as being the reciprocal of the associated positive exponent. So 2 to the negative 2 is the reciprocal, or 1 over 2 to the positive 2. Let's just try this one more time, see if we can notice if the patterns are the same, if the patterns change. If I have 10 to the power of 5, that's 10 by itself 5 times. One nice trick when I'm doing powers of 10, I don't have my calculator here with me today, but the exponent is going to tell me how many zeros I need. So every time I multiply by 10, I'm just adding a 0. So 10 to the power of 4 is going to have 4 zeros. So that's 10,000. 10 to the power of 3, 10 times 10 times 10 is 1,000. 10 squared is 100. And then 10 to the power of 1, I'm just writing down 10 once. So again, if we look for patterns, as I decrease the exponents by 1, I'm multiplying by 10 one last time. That's the same thing as dividing or splitting into groups of 10. So again, we're dividing by the base. If I keep that pattern going, 10 divided by 10 is 1. You might notice a pattern here that if I raise something to the power of 0, it looks like it always equals 1. If I continue that pattern, if I do 1 divided by 10, I could say 1/10. If I split each tenth into 10 parts, now I've got 100. So 10 to the negative 2 is the same as saying 1 over 100, which we could also write as 1 over 10 squared. So we notice these similar patterns, that when I have a negative exponent, it means to take the reciprocal of the associated positive exponent. If I divide by 10 again, I'm now going to have 1/1000th. Another way of writing that is 1 divided by 10 cubed. So just by following patterning, we've been able to kind of figure out or learn what zero and negative exponents evaluate to. So it doesn't always make sense to think about repeated multiplication anymore. I'm not multiplying this negative 2 times. But we've learned these two rules. The first rule is any base, I'll use a to represent any base raised to the power of 0 is 1. Doesn't matter if it's, 3 to the 0 is 1. Doesn't matter if it's negative 432 raised to the power of 0, it's still 1. I don't know. It could be a frowny face to the power of 0. It's still going to equal 1. So anything to the power of 0 is 1. That's what we've noticed by our patterns, because it's just the base divided by itself, which is always going to be 1. And then the negative exponents, if I take any base to any negative exponent, for example, negative m, I could rewrite that as 1 over, or the reciprocal of, the associated positive exponent. So for example, if I have 4 to the negative 3, I don't need to do this whole pattern. I can say, well, I know that's going to be 1 over 4 cubed, which is the same as saying 1 over 4 times 4 times 4. So 2 new patterns for you. What happens when I have a 0 exponent or a negative exponent? Try a few of those out in your calculator. You could try a few more to take a look at this pattern. So we've extended what we know about positive exponents, which is just the natural numbers. So now look at what happens if any first whole number, so that's including 0, or any integer, is up in our exponent position. Okay, that's all for now. Thanks for watching.